Hi everyone, today we're going to do a review of rational expressions. So yesterday you had your quiz on the first part of the review, so we're going to continue on with that. So let's start with first talking about what is a rational expression. This should be familiar to you, probably haven't done it in a while, but a rational expression is simply the quotient of two polynomials, right? So we did a whole long review on polynomials and what they are. And then a rational expression is just the quotient of those. So some examples of a rational expression would be something like 4 over x minus 2. Sometimes you'll have x or any variable in both the numerator and the denominator. Sometimes they'll be binomials, sometimes they'll be monomials, sometimes they will be trinomials. So those are just a few different examples of what rational expressions are. Now, when we are talking about rational expressions, we need to be very careful that we make sure we exclude numbers from the domain when we are writing it. So for example, let's take this expression 4 over x minus 2. If I were to write that as an answer to a problem, I would also have to include that x can't equal 2, because if I were to plug 2 in for x, that would make the denominator 0, and therefore this entire expression wouldn't exist. So make sure that you're very careful, and whenever you write an answer with any of the types of problems we do with rational expressions, be sure to exclude values from your domain that make that denominator 0. So for example, if you had the expression 2x over x squared minus 9, you would have to make sure that you exclude all values. So x cannot be negative 3 or positive 3. Sometimes people will write that as x can't equal plus or minus 3. You can write it either way, but just make sure that you do that. Okay, so let's talk about simplifying rational expressions. A common mistake that people make when they do this is that they try to cancel things that they're not supposed to cancel. So for example, if I had x squared minus 7x minus 44 over x cubed plus 4x squared minus 5x minus 20. Okay, I'm going to make sure that I factor the numerator and factor the denominator. What people always want to do is they want to start canceling here. Well, you can't cancel terms here because this x squared is part of this entire expression, or this 5x is part of this entire expression. So you cannot cancel part of a polynomial. You have to cancel only factors, which means you have to factor first. So if I factor that numerator, I end up with x minus 11 and x plus 4 as my two factors. But now let's look at the bottom here, the denominator. We have 4 terms, which means we're going to have to factor by grouping, which is something that we did the other day. So when we factor by grouping, we need to make sure that the product of the outside terms is equal to the product of the inside terms, which in this case it is. So if I go ahead and group my terms and take out my GCF, I'm going to take out my GCF of my first 2 terms. And then I'm going to go ahead and take it out of my last 2 terms. And so when I factor the bottom, I end up with x squared. I'll write it over here. X plus 4 and x squared minus 5. Okay, so those are my factors. So now I can simplify because I can cancel my common factors. So the factors I would cancel are x plus 4 and x plus 4. And that would leave me with x minus 11 over x squared minus 5. Now, you have to be very careful here because you have to make sure that you exclude the appropriate values from that domain. And if I go back to my original problem, I need to look at the values of x that would have made that denominator 0, which means from that I have to make sure that I exclude -4, and I also exclude plus or minus the square root of 5, okay? Because all of those values of x make that denominator 0. Okay, so pretty straightforward with simplifying. That should be a pretty easy review. Let's talk about multiplying rational expressions. When we multiply, some people like to multiply all the way through first, where others prefer to cancel first. I always prefer to factor and cancel first because it makes life a lot easier if you can get rid of terms before you start multiplying. So I have x squared minus 9 over 2x minus 5 times 2x squared minus 3x minus 5 over 4x plus 12. Okay, so I need to make sure that I cancel after I factor. So factor whatever you can. I can factor this up here, I can factor this, and I can factor this. So I end up with x minus 3 and x plus 3 over 2x minus 5. And here I end up with 2x minus 5, x plus 1. And here I end up with 4 times x plus 3. Okay, so I can go ahead and cancel. When you are canceling common factors, you can cancel things that are up and down, or you can cancel things that are diagonal, but you cannot cancel things that are next to each other. So one always has to be in the numerator, and one always has to be in the denominator. So I can cancel my common factors, and then what I'm left with is x minus 3 times x plus 1 over 4. And again, I'm just going to write it underneath because I ran out of room over there. Make sure that you exclude the appropriate terms from the domain. So I would say x cannot equal 5/2 or -3. Okay? Pretty straightforward. Again, you want to factor first and cancel after. Okay, let's move on to dividing. When we divide rational expressions, right, we're going to really do the same thing that we did with multiplication, except we have to do one step before we get to that. So if I have x squared minus 2x minus 8 over x squared minus 9 divided by x minus 4 over x plus 3. Okay. When we are dividing, the rule for dividing, right, because by definition dividing is just multiplying by the reciprocal. So whenever we divide rational expressions, we're going to make it very easy on ourselves, and we're just going to change this to multiplication and then flip that second fraction, because we're just going to be multiplying by the reciprocal. And so I'm going to go ahead and factor. If I factor x squared minus 2x minus 8, I end up with x minus 4 times x plus 2. And if I factor the denominator, that's just DOPS, right? Difference of perfect squares. And then again, I've now just turned it into a multiplication problem, and I can just go ahead and cancel my common factors, okay? And so that leaves me with x plus 2 over x minus 3, remembering to exclude values from your domain. So in this case, we have to exclude plus or minus 3, and we also need to exclude 4. And the reason being, the x plus 3 and x minus 3 come from here and here, but remember, when we turn this into a multiplication problem, we're taking the reciprocal here, and now I have this term in the denominator. And I can't multiply by this if this value is 0 in the denominator, so I wouldn't be able to complete the problem. So make sure when you're doing a division problem that you exclude everything that's in the denominator prior to multiplying by the reciprocal and after multiplying by the reciprocal. Okay, let's talk about adding and subtracting rational expressions. This goes way back to when you first did adding and subtracting with fractions, right? We need to make sure that we always have a common denominator. Same works with the with the rational expressions as did when you just were dealing with regular fractions. So if I have 7x plus 1 over 2x plus 5 plus 2x minus 22 over 2x minus 5. So I have this common denominator already. My denominator doesn't change. I'm just going to add my numerators together. I end up with 9x minus 21. Now, from here, you want to make sure that your final answer is in simplest terms, which in this case it already is. However, recognize that you can take a GCF out of the numerator. And if you take out a 3, then you end up with 3x minus 7. Over 2x minus 5. And I always encourage people to go ahead and do that because that's still technically correct. It's just the factored form. But I like people to do it so that they can make sure that it is in simplest form. If you get to this step and you can reduce, then you want to make sure that you reduce. Don't forget your exclusions here. We have to exclude 5/2, right, because that makes our denominator 0. Only thing you need to be careful of is when you are doing a subtraction problem. For x squared minus x minus 6. A lot of times people make careless mistakes with these types of problems because they in fact forget sorry, I'm writing and talking at the same time. They forget to distribute that negative. So that negative needs to be applied to the 4x as well as the 4. Okay, so when we distribute that, we end up with x squared minus 4x minus another 4x. So we end up with x squared minus 8x minus 4. All of that over x squared minus x minus 6. Now I'm pretty sure you cannot factor that numerator at all. And so there's nothing that you can cancel. So please be careful of that because oftentimes people make careless mistakes and they forget to distribute that negative. And sometimes people get here and they're just not thinking and they want to start canceling things. Fight the urge to cancel here. If you can't factor it, you can't cancel it. Okay? All right, so that's if you have a common denominator, but let's talk about when you have unlike denominators. So for example, if you have 3 over 5x plus 2 minus 5x over 25x squared minus 4. Okay, so clearly we have different denominators here. And hopefully if you look at this, you recognize that this actually is difference of perfect squares. and that you can factor it to 5x minus 2 and 5x plus